Brother, you are welcome. Thank you once more. Thank you. Objective of the lesson. By the end of the lesson, you should be able to recognize symbols for both truth and false statements. 2. Negate both false and true statements. 3. Set up truth table for various statements investigation. 4. Determine the validity of statements using truth table. Introduction. In this lesson, we will demonstrate that truth tables are the representation of statements in terms of symbols and show how connected these statements are. These statements can either be disjoint or not disjoint. Symbols will be given to represent both false and true statements. This will start by defining what a statement is and type of existing statement. As earlier mentioned in the introductory part, a statement is an expression of words which may be 1. Declarative, factual, interrogative, questions, exclamatory, sudden feelings. This unit will focus on declarative statement. The fundamental property of a statement is that it is either true or false. Type of statement. There are 4 types of statements: simple, compound, atomic, and molecular statement. A simple statement is that which makes single sense. Examples: he is very clever, he is active. A rectangular has 4 sides. I am going to the mall. He has creative ideas. Supply is the ability to deliver. Compound statement. A compound statement is made up of 2 or more statements. In other words, it passes down more than one information and has other statements as its components. Example of compound statements are as follows: I am going to the shopping mall to buy some goods and I shall be back in the next 40 minutes. Adesola Adeyemi is a friend as well as a Muslim. The first statement here has 2 things. I am going to the shopping mall. And the second one, I'm going to the shopping mall to buy some goods. And the second one, I shall be back in the next 40 minutes. These 2 things make it a compound statement. The second one, Adesola Adeyemi is a friend. That is one component, as well as a Muslim brother is another component. This makes it what? A compound statement. The sum of 3 angles of a triangle is equal to 2 right angles, and the sum of lengths of 2 sides of a triangle is greater than the length of the third. The word "and" at the middle connects the 2 components of this statement, and that makes it a compound statement. Roses are red and violets are blue. Roses are red is a component, violets are blue is another component. The higher the price, the more the quantity supplied. The lower the price, the lower the quantity supplied. This has about 4 components. The higher the price is a component, the more the quantity supplied is another component, the lower the price, the lower the quantity. These are 2 other. There are about 4 components making the statement a compound statement. Declared statement. Statement declared are represented in terms of symbols called connectives. These symbols are either in capital letter or small letters. Say P capital, Q capital, Z capital, P, Q, P, R, and Z small letters. The class statements are assigned true or false values, but not at the same time. The symbols for true value is denoted by capital T or sometimes small t, depends on the individual, and for false value shall be denoted by capital F or small f, depends on the individual. The symbols right arrow and left and right arrow are called implied symbols. Atomic statement. A statement without connective is called atomic statement. They are assigned atomic variables. Molecular statements. A molecular statement is that which contains one or more atomic statements, and some connectives is called molecular statements. Example, given a statement, say P, the negation of P is denoted by not P, where not P stands for negation operator. This implies that if P was true, then P, not P, implies false. Or if P was false, then not P implies true. Given a statement R, if R is assigned a true value T for truth or false, the corresponding value of R for not R shall be represented in the tabular below, table 1.1. Conjunction of statements. Given any two statements, say P and R, the conjunction and between P R is denoted by P wedge R, where the wedge stands for and the truth table is represented below. This shall serve as a model for consequence problems and examples that you might come across later in the course of this lesson. Disjunction of statement. Given any two statements, say P and R, the disjunction between P and R is denoted by P with a V-shape operator and R, where the V-shape operator stands for or. The truth table representation is as below. You assign T for R, T for P, T, F, F for P, R, F, T, F for R. The disjunction is determined in the column 3, P or R. This also shall serve as a model for all consequence examples you may later come across. Implied statement. Given any two statements, P and R, the statement P implies R means given P implies R is called a conditional statement or implication. The truth table is given in 1.1.4. Example, given two statements P and R, construct the truth table for the combined statement not P or not R implies P. The solution is the table given below by the use of the already defined operator or and implied tables above. By implication, given any two statements, say P and R, the connective P, if and only if R, means if P and only if R is called a biconditional statement. The truth table of such statement is as below. as is defined in table 1.16. Table 1.16. This will serve as a model for other examples and problems you might later come across. Example, construct a truth table for the statement not P or R if and only if not P and R. The solution is in 1.1.7, and with the application of all the operators defined above, column 7, column 6 is achievable. The following activity are meant for you to practice for better and effective understanding of the lesson above. Given any two statement P and R, write out the truth table for the following. These are all defined. With the application of the above tables, all these are achievable. Activity 1.2, you are also to apply the above truth table defined to achieve these particular problems. Also, with the application of above table, this also can be achieved. That is the problem in activity 1.3. Summary of conclusion. Various symbols, connectives of connectives have been explained, and how their truth table can be achieved has also been displayed. Several types of statement formulae and how they are connected with the assigned variables has also been displayed. Conclusion. At the end of this lesson, we believe you are now able to recognize symbols, statements, and their connectives, and that you can verify statements using truth table. There are some references you can go through if you want to further your knowledge in symbolic table constructions. These are references.